Yes, sir.
All
It's
right.
accessible.
All right. Great. So first thing that we talk about here in CCNP NRC is routing, right? Because the majority, the majority of what we have under NRC is your routing. Now, under the routing, we are going to talk about dynamic routing protocols, right? Now, previously in CCNA part, right, under CCNA, you have learned what is a static route, right? Where on every router, the administrator himself goes to every router, logs into every router, and adds a static route, right? If an administrator adds a route, it is known as a static route. Now, dynamic route is something which is done by the protocols. What are the protocols? The protocols are EIGRP, OSPF, right? So these are the dynamic routing protocols that we'll learn. And also we will learn BGP, which is an exterior gateway protocol. Now, these two are called as IGP. Why? Because they are used within our own organization, within an autonomous system, AS, autonomous system. I'm sure you would have heard about the word autonomous system as well in your CCNA, right? Within the autonomous system, if you use any protocol that is known as interior gateway protocol, outside, that is between two autonomous systems, let's say one company is trying to talk to another company, there you use something called as exterior gateway protocol. Now, is exterior gateway protocol itself is a protocol? No, it's a name. And what is an exterior protocol? BGP is an exterior gateway protocol, right? It acts as a gateway between two autonomous system, different autonomous systems. So we'll be learning EIGRP, OSPF, BGP, and then we'll move into VPN concepts. That is the schedule for the CCNP NRC. And you will not only be learning what these protocols are, but you will be learning something in depth, right? Having said that, we can move with EIGRP as our first routing protocol. But before that, let me ask you, are you guys aware of how to add a static route? Do you guys know how to add a static route?
Yes, sir.
Okay. Have you added it already when during the lab or something? Have you executed that?
Yes, sir. Yes, sir.
Yes, sir. Yes, sir.
Okay. Okay. And also, I believe that you guys, to some extent, also know about OSPF, EIGRP, some
Yes, sir.
basics, right? That is awesome. Okay. The first protocol that we are learning or starting off with is known as EIGRP. EIGRP stands for Enhanced
Interior Gateway Routing Protocol.
Interior Gateway. That is good. That is correct. Gateway Routing Protocol.
Protocol.
So EIGRP is one protocol which actually helps us to exchange the information between two routers. It is one of the routing protocol. Now, when we say, let's take a simple example of two routers, R1, R2. They are connected by 1111 and 1112. Now, first thing that we need to know or understand is how to enable EIGRP. Now, from the CCNA classes, obviously we know how to enable EIGRP. First thing on R1, if I need to enable EIGRP, I will say router EIGRP and I will give a autonomous system number.
190 lakh.
Exactly. You can give an autonomous system number of whatever you like from 1 to 65,535. Right? These many autonomous system numbers you can use, but within the same organization, you have to use the same autonomous system, right? Let's say 10. Let's all sync up with 10. Now it means that EIGRP is enabled on R1. Now if I type the same command, router EIGRP 10, means that I have enabled EIGRP on router 2 as well. Now, when I say I have enabled EIGRP, it means that both the routers, right, both R1 and R2 can now hear and send EIGRP updates to each other. But not automatically. The administrator will decide when to send the updates. Now, when I say, do you guys understand what is a multicast address?
Yes, sir.
Okay. So what is the multicast address of EIGRP?
224.0.0.10.
Correct. Absolutely right. Now, this is the multicast address of EIGRP. Till now, the router that you were seeing, without this command, the command that I'm talking about is this one. Without enabling this command, right, on this router, on these two routers, without enabling this command, let's say a packet is now coming to R1. Okay, maybe R1 is connected to some computer or maybe any other router. Okay, this packet is coming towards R1 from R10. Now, this packet has a source IP of R10. Let's say 5555 is the source IP. Destination is 224.0.0.10. Will R1 allow this packet or no? Or will it deny the packet? What do you think?
Allow, sir.
Okay, why do you think will it allow?
It is multicast address, sir, which is already.
It is a multicast address, I agree. But
And
when will this router start supporting this multicast address? To give you the answer, this router will start supporting this multicast address only when it is enabled with EIGRP. Okay. When you don't have this command enabled on the router, then this packet flows through R1. It will see, okay, what is the destination? 224.0.0.10. No, I am not supporting this kind of address. I don't know this address. It will drop the packet. But after you enable this command on this router, then it will see again the packet. Maybe you will send a second packet. Same, from the same source to same destination. Now it will say 224.0.0.10. Okay, I will support it now because I am enabled with EIGRP. Then it will accept the packet and process the packet. Does it make sense? Any doubts?
No, sir.
no, sir. Thank you, sir.
Now, both routers, according to us, are supporting EIGRP. Means if any packet comes to this router or this router, packet is just a message having information like 1010. On top of that, it will have source MAC, destination MAC, On top of that, it will have source IP, destination IP,
Yes, sir.
right? This is what usually a packet has, correct? Now this packet will now come to R2. It will be accepted or processed by the router because it is enabled with EIGRP, right? Now, moving further, it is similar to, for example, I am just trying to make sure you guys are understanding. So I'm just repeating it again. Until and unless you are a subscriber of Netflix, you don't get to see recently added movies because the subscribers will be sent new information on a different multicast address. This is a subscriber. This guy is a subscriber. So he will be sent new movie information to his login details by a different multicast address. But some guy who has not taken subscription will not get that. Will not get it to his, he will not be added to the multicast address. So multicast address is nothing but a group of users. For example, you belong to a NOC team or operations team. One single mail sent, you can all see that mail because you are added in that multicast address. I think it is Sri Chakri. Can you place yourself on mute? Now, if you are out of the group, then you won't be getting any multicast or any emails sent to the NOC team. So it is a group of address. I am addressing only CCNP batch in November. So October batch, which is going on, cannot see whatever information I'm sharing with you. It is a group of users who can hear and communicate through that address, right? That is a multicast address, right? One to a group. One to one is unicast. One to one is unicast. One to a group is multicast. One to everyone is broadcast. These are the three types of communication we have in networking. Okay. Now, where were we? We were here in the first command of ours, router EIGRP 10. By enabling this command, these two routers will be understanding any packet that will be sending information to 224.0.0.10. Awesome. Now, after this, to make these two neighbors is our second thing. So first thing is what? Enabling EIGRP. Second thing is establish neighborship between the two routers which are connected directly, right? You cannot establish a neighborship from here to here. The routing protocol to become neighbors, the routing protocol should have the two routers directly connected. Okay. Now, the second thing is establish neighborship. It is similar to, there are two people, only after they become friends, there will be some secret information exchanged between them, right? Only after they are friends, they become friends, the information is exchanged between each other. So for that, first of all, they have to be neighbors. They need to get to know that they are neighbors, right? For that, what we need to do? We have to advertise this network, right? We have to, how do we establish neighborship? By advertising the network connected between them. connected between them. If we advertise this network, now what is the network connected between R1 and R2? What do you think? You guys can hear me?
Yes.
Okay.
Yes, sir.
What is the network that is, okay, somebody also sent me an answer over that is correct. Exactly. That is right. What do you think is the network that is connected between R1 and R2? Anybody?
1.1.0.
1.1.1.1. That is correct. Exactly correct. Now, if I say 1.1.1.1, it is not a network. It is an IP address that is configured on R1. If I say 1.1.1.2, it is also an IP address that is connected on R2. It is not a network. So 1.1.1.0 is a network where these two IP addresses are a part of that network. 1.1.1.0/24 is a network in which these two IP addresses are a part of. Okay. So what I'll do is I will go and advertise that one here. Now, what do I do to advertise? Do you guys know how to advertise a network in EIGRP?
Sir.
Network
Network.
1.1.1.0, wildcard mask, wildcard bits. That's all. Right? The same thing here. Network 1110 and the wildcard bits. This is how you advertise a network. Now, if you want these two to be neighbors of each other, you advertise the network.
Hello, Rahul.
Yes, Ramesh, go ahead.
Why in some places we use wildcard mask and some places subnet mask while
Exactly.
addressing routes?
Good question. So, IP address, when you assign an IP address to a computer, you have to give a subnet mask. The routing protocols are designed in such a way that it will ask for a wildcard mask. Now, if you ask me how to find out the wildcard mask, see, the global mask, the global subnet mask is 255.255.255.255. And let's say the subnet mask of this network connected between R1 and R2 is 255.255, let's say the subnet mask. Okay. This is the subnet mask. The subnet mask is 255.255.255.0. Now, how to find the wildcard mask of this subnet mask? Simple. The wildcard bits of this subnet mask is nothing but you subtract this one from this one. The global subnet mask minus the actual subnet masks. So what do you get? 0, 255 minus 255, 0, 255 minus 255, 0, and here 255. This is your wildcard bits. The protocol is designed in such a way where we use only wildcard bits, right? The way to find out the wildcard bits is like this. Now, let's say that we got another subnet mask. Let's say the subnet mask is 255.255.0.0. Then the wildcard bits will become 000.255.255. Now, let's say we have 000. Instead of 255, we have 252. Sorry, not here. This is 255. This is the subnet mask of something is 255.255.255.252, then the wildcard bits will become 0003. This is how you find wildcard bits in advertising a network. Hope that makes sense. Now, if you want the neighborship between R1 and R2, you are advertising the network between R1 and R2 in the network command. But by chance, if you want a neighborship between R5 and R1, which network do we need to advertise? We need to advertise 2.2.2.0 network on both R1 and R5. Is it making sense? Any confusions? I'll take that as no.
No.
Okay.
No, as of
So if you want to make neighborship between R1 and R5, you have to advertise the network connected between them. If you want to advertise, or if you want to establish the neighborship between R1 and R2, then you have to advertise the network on both routers connected between them. Okay, as simple as that. Now, when you advertise this particular network, immediately there is a hello packet, right? It is called as a hello packet. The hello packet will immediately go out of this network. Now it will see, you know that every router has a routing table, right? Now, can anybody tell me what is inside the routing table of R1? Can you guess what is inside the routing table of R1 just by looking at the router here that I've drawn?
Sir, interface, router interface.
Let me write the interface, then here and here. Now, can you tell me the routing table, how it looks? What is the command for routing table, first of all? I want
So
to...
IP route.
Exactly, awesome. That is right.
Show IP route.
Correct. So show IP route is the command to check the routing table of R1. Now, if I enter show IP route on R1, what will be displayed? What does it display?
It will display the routes, like connected route static and whatever the routes learning from the EIGRP, it will show.
No, right now, I want you to answer just by saying this. Now, I have just enabled EIGRP. Without enabling EIGRP, what is that it will display? Always the connected routes. You were right? Every router will, if you don't have any static route, if you just take the router, okay? You just take a router. Okay, sorry. So did I disconnect anybody? No, I don't think so. Raj Singh. Okay, he's on the call. Yeah. Raj Singh is on the call. Right. Always the router displays its connected network in the routing table at first. When you don't add any static route, no dynamic routing protocols, nothing added. You just took a router, configured an IP address on it, and you connected with another router which has an IP address on it. You have not done anything. You have not done anything, right? So at that point of time, the routing table will only show the directly connected network. Now, I'll ask another question. Now, I don't have this IP address configured on this router. What will the routing table show?
Nothing.
Exactly. Good answer. It will not show anything. Whenever you configure an IP address with an interface, right? Let's say this is 5.5.5.1. let's say this is 6.6.6.1. Then the routing table shows I am directly connected with 1.1.1.0 on F0. This network is connected on F0 bar 0. Then I have 5.5.5.0, which is connected on F0 bar 1. Then I have 6.6.6.0, which is connected on F0 bar 2. Always the router will show the directly connected interfaces in the routing table. You have to know this. Even without entering a show IP route command, you should know that, okay, so this router R2 is connected with, is configured with 3 IP address or 4 IP addresses. So obviously routing table will have all these 4 networks in the routing table without doing anything, without the routing protocol, right? At first, it will have these things in the routing table. It should automatically strike your mind that whatever networks are connected to that router, that will be in the routing table, saying that so and so network is connected with so and so interface, right? Now, if that part is clear, moving on. Now,
Hello, Rahul.
yes.
So if directly connected network, it shows in the routing table. So for example, here 111.0.
Mhm.
So why we should again advertise in EIGRP, that one?
Because there is lot of networks. Now let's say there is 5.5.5.1, 6.6.6.1. Okay. There are 3 directly connected interfaces in the router. Now you want to advertise only 1.1.1. network in EIGRP, but you don't want 6.6.6. network in EIGRP. Maybe you want 6666 in OSPF, right? So this advertisement, what it does, it actually tells you that 1.1.1. network now is a part of EIGRP protocol. It can be shared with another router over EIGRP protocol. But 6666 network, he has not given a network command on 6666. Means he has not advertised 6666 network. Means that network cannot be shared to the other router over EIGRP protocol. Maybe you can share it with OSPF. Depends. Make sense?
Okay, got it.
Yeah. Now, directly connected networks. Now, R1 has this network in the routing table. R2 has same thing, 1110 connected to F0 bar 0. This is the routing table of R2. Correct? Now, immediately I told you, as and when you add a network command, a hello packet will be formed. This is a hello packet. Now, hello packet will check. Network command always triggers a hello packet. Always it triggers, it generates a hello packet. Now, as and when you give a network command, immediately router will say, okay, I have to send out a hello packet. From where? From the interface which is configured with this network. Now let me check the routing table. Which interface is configured with? Okay, the interface is F0 bar 0. Now it will see F0 bar 0 actual IP address is 1111. So it will form a packet. The packet source address is 1111. But I am sending this packet to the destination. Which destination? This is a EIGRP hello packet. All the EIGRP packets have to be sent to 224.0.0.10. So it will send a hello packet to R2. Not exactly to R2. It will send a hello packet over this interface. Means out of this interface. The router generated does all the calculations here. Now it sends a hello packet out of this interface. Now, if it sends out of this interface, where will the packet go? Obviously, the other end of the interface, the other end of this wire is R2. So obviously, the packet makes its way towards R2, right? R2 will check, okay, I got a hello packet from somebody. He is 1111 and he has sent it to 224.00.10. Destination of that packet is 224.00.10. Obviously, I'll support it because even I am enabled with EIGRP. Somebody enabled, some administrator enabled EIGRP in me. He wrote the command. So I will process this information. Now, what is he saying in this packet? He's saying it's a hello packet. And he also says my autonomous system number is 10. And he also says my hello packet will be sent every 5 seconds. If you don't reply, I will consider that you are dead. If you don't reply for 15 seconds, I'll consider you are dead. That is his hello interval and dead interval. That is what these packet carry. This packet will have so much information in it. It is called as a hello, EIGRP hello. It will have source address, destination address, AS number information, hold timer, and K values. We'll talk about the K values. And also whatever the neighbors are, if it has any neighbors, it will have a neighbor field where it will say who are the neighbors of this. Those are
Hello,
those.
Rahul.
Yeah. Any question?
If R2 is sending any hello packet, what will be the destination?
Same thing. So R2 is sending a hello packet. Oh, which hello are you talking about? EIGRP hello, OSPF hello?
EIGRP.
Exactly. So EIGRP destination is 224.00.10. Okay.
Okay, same time it has as a destination and as a source also.
No. Source will be the interface out of which it sends a hello packet. That is the source, right? Because it is, if R2 is sending out of this interface, then that interface IP address will be the source IP, right?
Okay.
Yeah. All right. Now, these are the things which are carried inside the hello packet. Now, this guy will check. Okay, he has sent me the hello packet with lots of information. Okay, my AS number is also 10. My hold time, dead time is same as this guy. And he has sent an EIGRP information to me. So I received a hello packet from him. First, I will see, does this match? Does this match? Does this match? If everything matches, also there are some K values I'll tell you in future while we deal with EIGRP. He sees if everything matches, then yes, okay, I can add him as my neighbor because I received a hello packet from him. R2 will say, okay, in the neighbor table. Now there is always a neighbor table for every protocol. In that neighbor table, it will update saying that I have a EIGRP neighbor table. So it will go to the neighbor table. Inside the neighbor table, EIGRP, every router maintains whichever router you enable EIGRP, it maintains EIGRP neighbor table. And that can be seen by the command. You guys already know it. I'm just reminding it to you again.
So EIGRP neighbors.
Exactly. That's right. Show IP EIGRP neighbor. Right? Now, R2 will add 1111 as the neighbor. Why? Because you saw the source, right? The source of this packet was what? 1111. Destination was 224.00.10. So from where the packet came? From here.
Sir,
Go
hello.
ahead.
Sir, I just lost in the middle of the class. Sir, why we have taken a destination as 224?
Because this is an EIGRP packet. All the EIGRP routers, when they send any hello packets, it will be sent to 224.00.10. Right? So because I am working in radio, okay? If I want to give any information to all the 93.5 FM listeners, I will only speak out the information in that particular frequency. Nobody else will hear that. So here also, if EIGRP router is sending information, if an EIGRP router is sending an information and it wants only other EIGRP routers only to hear that information, it will send the information to 224.0.0.10. So that that is the communication address for EIGRP routing. Make sense?
Okay. Yeah, thank you, sir.
Okay. Now, this guy updated the neighbor table. Now, he also has a network command, which also triggers now a hello packet. When you see a network command for an interface, whenever the network command is written, a hello packet is triggered. Now this guy will also generate a hello packet. Okay, hello packet. What should be the source? What should be the destination? Now this network command says, hello packet should go out of 1.1.0 network. Now it will check the routing table, router. 1.1.0 is connected to F0 bar 0. And what is the IP address of F0 bar 0? 1112. Okay, I have to send out a hello on that interface, this interface. So source will be the IP address of that interface, which is, sorry about that, give me a minute. Okay. Okay, the source is 1112, right? Because the hello packet should go out of that interface, which is F0 bar 0. Destination, again, now, it wants only EIGRP routers to hear the hello packet 224.0.0.10. It could have sent to 1111 also, because when this packet was coming in the red packet, it had the source IP 1111. So this guy already knows I am connected to 1111. He is my neighbor, but he will not send it to destination address 1111 because there might be a switch in between. There might be other routers, EIGRP routers also, right? So if I send it to 224.0.0.10, whatever the routers are, they will all get EIGRP information. So what he'll do, he'll use the multicast address 224.0.0.10, generate a hello packet, and also AS number information he'll put in there. Hello interval, dead interval, everything he will add inside this hello packet, and that hello packet generates on the router and moves out of F0 bar 0. When it moves out of F0 bar 0 inside this wire, obviously the other end of this wire is this guy. Now R1 will update his route as and when he receives the hello packet here. R1 will say, my neighbor table 1.1.1.2 is my neighbor. Okay. This is how the neighborship forms in EIGRP, protocol. Now, I know I'll ask some silly questions. So, one silly question again, which I have is, now, let's say that I don't have a network command. Will there be a neighborship? I don't have this network command, this one, on both the routers. Will there be neighborship, EIGRP neighborship?
Could you repeat your question, please?
So I have just written this command on the router and on this router. Will they both be neighbors?
No,
Yes.
Why is it a no?
because you didn't advertise a connected network.
Exactly, that is right. So I gave on R1, I configured router EIGRP and I gave network 1110. On R2, I configured this command, router EIGRP1. Now, will they be neighbors?
Still no.
Still no, because advertisement on both the routers are required to send a hello packet out of the interfaces. Only when they see each other's hello packets, they get to know they are neighbors. Make sense?
Yes.
Awesome. All right. So that is about the EIGRP neighbor table, right? EIGRP neighbors, EIGRP adjacency, right? Now, moving on. Let's add a bit more to it. Let's learn a bit more of some concepts. Now, I have a loopback interface on R1. Okay. The loopback is 10.1.1.1. Now, don't be confused. What is a loopback? Loopback is just another interface like this. It's configured with the IP address 10.1.1.1. Now, I have another loopback here on R2, which is 20.1.1.1. Now, does it, so I added this loopback 0. This is the interface. This is a loopback 0 interface. Now, I added an IP address on the loopback interface. Does it change the routing table of R1 or does it remain the same?
It will add. It will change. Like it will show the connected route as well for the loopback.
Exactly. So it will add to the routing table 10.1.1.0 network is connected to loopback 0. Now, again, here 20.1.1.0 network is connected to loopback 0. See, the routing table got updated as and when I added a new network. Now, since these two are already neighbors, why they are already neighbors? Because I have given these two commands on both these routers. They are already neighbors. Does these routers exchange the loopback information with each other since they are neighbors?
No.
What has to be done to exchange the information?
We need to advertise the loopback address also in the EIGRP.
Exactly.
Yes.
Network.
Right? Okay. Now, again, when I say network 10.1.1.0, 0.0.0.255. Again, if I say this, there will be a hello packet generated and it goes out of this wherever that network is configured. Out of that interface, a hello packet goes out. That is the first thing. Second thing is the router will check whoever is my neighbor. Since I am advertising this network information, he should have this network information. My neighbor should have this network information. It will again generate an update packet. Inside that update packet, it will send to the neighbor. Now, who is the neighbor? Let's see the neighbor table. The neighbor of R1 is 1112. Okay. So this is sent to. Now, what if there are many neighbors? Another, right? There can be. So what it does is update packet is also sent from 1111 to 224.0.0.10 because it is an EIGRP update packet. Inside the update packet, what you will have? Inside the update packet, it will have, I have 10.1.1.0 network and the subnet mask is 255.255.255 or wildcard. Okay, .0. This is the network information that I am connected to. This is the update that I wanted to send you. So it will send an update to R2. The minute it goes to R2, R2 will immediately add that in routing table or topology table. 10.1.1.0 network, I know now. How do I know? Because it was sent as an update to me. From whom? From 1.1.1.1. He is my neighbor. So it will trust whatever the neighbor gives. So it will add it. Now this guy, whatever, now see the routing table of R2 and see the routing table of R1, right? Now you know how these routing tables are formed, right? Through this EIGRP update packets. If we advertise something, it will go as an update to the neighbor. And that neighbor adds that piece of information in the routing table, topology table. I'll tell you what is a topology table, right? But before moving on, I have a question. Can this router, or let's go to this router. If I try to ping 1.1.1.1 from R2, will there be a successful ping response or no?
Yes, there will be a
Yes,
success.
it will.
It will ping. Okay. You know what is the ping protocol and all that, right?
Yeah.
Yeah.
Awesome. Now, from R2, if I try to ping 10.1.1.1, will it ping or no?
It
No,
depends. It depends. If you
No.
pinging from
no, it will not.
1.1.2, then
See the
it will
configuration and
ping.
see the configuration.
No, no. In EIGRP, we not added here at R2 end, so it will not ping.
No, I think it will be ping because if we get like taking the source of F0 by 0 interface, then it will ping. Otherwise, if we are using interface for like the
Let's say
loopback,
we are pinging from 1112
yeah,
to 10111. Will it
yeah,
ping?
then it will ping.
Yes, sir.
Okay.
Yes, yes, ping. It will
We
ping.
are pinging from loopback 0 to 10111. Will it ping?
No,
Yes.
No, we don't have that network in R2.
If we
yeah,
are adding in EIGRP any network, only that one we can ping. Rest we can't ping.
Exactly. So see here, I have advertised 10110 from R1. So R1 is sending the information of 10111 to R2. And R2 has updated that 10110 network in the routing table, right? Now, from R2 F0 bar 0, can you ping 10111?
yes,
Yes. Next, from this loopback interface, can you ping 10111?
no, because R1 does not have the route up to 20.1.1.1.
Exactly. So this is where people get confused. Be very, be very basic about it. I mean, you should know these basics. Now, when I say I am pinging from 1112 to 10111, okay? What is the source? 1112. What is the destination? 10111. Now, this is the packet. Okay. Now, this router, before pinging, immediately does it send the packet this side? No. First, it will check the routing table, which is the destination I want to ping, 10111. Let me go to my routing table and check, do I know how to go to 10111 network? So routing table says, yes, 10111. If you want to go to 10111, then you have to go to 1111. Now, how to go to 1111? Again, from the first line, where is 1111? It will start searching. Okay, in the first line, I have to send the packet to F0 bar 0 network. So it will send the packet out of F0 bar 0, this ping packet I'm talking about. Now, this ping packet reaches R1. R1 will see the source is 1112. Destination is 10111. Now, where is 10111? Let me check my routing table. 10110 is connected directly to me, loopback. So, no problem. I will send the packet to the loopback interface. That is your one-way packet. Now, this loopback decides to respond to the sender. So, The source is 10.1.1.1. Destination is 1.1.1.2 because he was the person who was pinging me. Now, this is the packet. As and when a packet is formed, the router will check 1.1.1.2 is the destination. In my routing table, do I have a route for 1.1.1.2? Start from the first line. Okay, I have to send for anything which goes to 1.1.1.0, I have to send the packet out of F0 bar 0. That is the first line which says that. So I'll send a reply packet out of F0 bar 0. The packet will be received at R2. R2 will check. The source is 10.1.1.1. Destination is 1.1.1.2. Where do I have 1.1.1.2 inside me? Yes, on F0 bar 0 interface. It will directly have it on F0 bar 0 interface, right? That is the to and fro packet. So you have to think both the ways. Now, the second scenario that I told you, second scenario, okay? Let's talk about the second scenario. In the second scenario, I want you to ping from where? From 21.1.1, I want you to ping to 10.1.1.1. Actually, let me erase this. It is creating a confusion. Right, I'll just erase this so that you can see it clearly. 1 second, give me 1 second. F0 bar 0, right? Now, this is loopback 0. This is 10.1.1.1. Okay. Now, the second scenario that I gave you is I want to ping 10.1.1.1 from, from this guy, I have to go to this guy. So source will become, there will be a packet generated on R2. Source is 20.1.1.1. Destination is 10.1.1.1. Immediately, this guy will check the routing table. Hey, some packet is generated. It wants to go to destination 10.1.1.1. Let me check if I have 10 network. Okay, for that, in the third line, I got an answer. I have to go to one network. Again, where is the one network? Start searching from here. First line, there is an answer. Send out of F0 bars. It will send. The packet will come here. Which packet? Same packet. This router sees what is the destination to 10.1.1.1. It will check the routing table. 10.1.1.1, go to the loopback interface. Okay, loopback interface. Packet is received to the destination. Fine. Now the loopback interface 10.1.1.1 has to reply to the sender, who is 20.1.1.1. Immediately, it will generate a packet. Now the router will check what is the destination I need to send it to? 20.1.1.1. Do I have that in my routing table? No. Right? So the response cannot be sent. When the response cannot be sent, the ping will fail. Right? It does not know where to send it to. It is just like I am writing you a letter and I want a response from you, but I have not written my door number. How will you respond to me? You cannot. The ping will fail.
I have a question. Hello.
Yes, go ahead.
Yeah, for the R2, if we are not adding network 10 or 20, so is it possible to we can ping from R2 to R1 loopback IP?
Repeat again. So you mean to say that for R2,
Yes.
you don't want to add this command you're saying, this
No,
one.
no, 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 no. I mean, if network 10 here be not adding, so is it possible to ping from R2 to 10.1.1 this IP? Like in R1 be adding network 10, okay?
So you
But
don't want to add
in
this
R2,
line, correct?
yeah, R1 we are adding here, but for the R2, is it compulsory to add for the R2 as well, or we can't add?
We
It
can.
will ping.
we can add 20.network here. You mean to say, so let me actually understand it correctly. Now, in R1, I have added network 10.1.1.0, right? Inside the EIGRP protocol. Now, under R2, you want to add network 20.1.1.0 or the same network 10.1.1.0?
Yes,
What do you want to
same,
add?
same 10.
The same 10 network, you can add it only if it is one of your interfaces. If you see R2, see, this is 1112. This is 20111. Now, are there any interfaces with 10111?
No,
If there are no interfaces on a router with that particular network, then you cannot advertise that network.
got it. Thank you.
Okay. Yeah.
I have one query about this.
Yes.
If we use a network, like if we advertise the 10.1.1.0 from the router 2,
Okay.
it will go advertise or it will check, okay, it is a connected interface or not
So
first.
first of all, when you say, see, I'll say network 10.1.1.0 and I'll give the wildcard bits correctly.
Mm-hmm.
First thing it'll do is, where is this network? It will check the routing table. Some command has been given in EIGRP. Under EIGRP process, there is one network command. The router will check, is this network command existing in the routing table? Do I have it in the routing table? Now, in the routing table, there is nothing as 10.1.1.0 network, right? There will be no 10.1.1.0. This is obtained from router 1. So forget about this one. Before getting this from router 1, there was no 10.1.1.0 network anywhere. So it will definitely not send anything. So for example, when you give network 1.1.1.0, right? When you gave this command, network 1.1.1.0, the router checked where is 111 network. It is on F0 bar 0. Then let me send a hello packet out of that interface. Now, if you give network 10.1.1.0, then it will check where is this interface. If it does not get any interface for that network, from where it will send the hello packet? It won't. Make sense?
Yeah.
Right.
Why I'm asking this thing, because last time I learned it that if we are applying EICRP, so suppose that in single topology we have multiple routers, 10 routers. So every network we need to add for the every routers.
No. So you mean to say 10 dot network will be on R2 as well. And if there is an R3, 10 dot network will be on R3 as well. Do you mean to say this?
Yes.
Not at all right. Not at all right.
Yeah,
So
this was my
I'm
confusion. That's why I
no, no,
asked.
no. So simply to answer your question in a different way, let's say that you have a printer. Okay. You have a printer, the printer's IP address is 5.5.5.5. And that printer is somewhere connected here. Okay, you want to give the instruction to the printer. Now, if every router has 5.5.5.5, this is a server, this is a server.
Correct.
Now,
Got
if
it.
you are sending the information, it has to go to the printer, right? It will be not a correct routing, right?
Right.
Yeah. So first of all, there is a rule of IP address that there should not be two IP addresses used. The two networks cannot be repeated. If you use a network once, that's all. You cannot use that network again. Right? Say, similarly, the IP address. If you use an IP address once, you cannot use it again. It is only used once, only once. Okay? Because it will create suboptimal routing. Make sense, guys? Did you understand?
Got it. Thanks.
Right. So today what we learned is, we learned about the EIGRP neighborship. EIGRP neighborship. And first of all, what we did for neighborship? First,
We send hello to each other.
exactly. First one, we enabled EIGRP. You know how to enable it now? How did you enable EIGRP? By the router EIGRP command. Second thing is, you advertised the network connected between them. Then they became neighbors. Then whatever you advertise will go as an update to the neighbor. Does that make sense? These are the three steps we followed, and we also could see the neighbor table. How the neighbor table was formed during the EIGRP neighborship. Are these concepts clear? Any doubts on these concepts?
No, all clear.
Hello, Rahul.
Yes.
Only direct connected routers will form the EIGRP neighborship.
Correct. Exactly. The routers should be directly connected for forming neighborship. If you think of a scenario, okay, now let's say router 1, router 2, router 3, router 4. This is 1111, 1112. Can you see my diagram, you guys?
Yes, it's visible.
This is 3331, 3332. Okay. Now you guys tell me, looking at the router 1, what is the routing table of router 1?
1110.
3.0.
Exactly. And is that all?
2.0.
It is connected to the interface also, you have to tell. It is 1110 network connected. You should always have that as well. Okay, in the routing table has the interface that is connected also. Now give me the routing table of R2.
1110 and 2220.
F0, 2.0, F0, 1.
Okay. Now what about the R3? 2220, 3330.
0.
This is connected to F00. This is F0 bar 1. Now R4. R4 in the routing table 330 connected to F0/1. Right? Now you guys know how it looks. Now when I say here to this guy, I'll enable router EIGRP 10 on router 1. Okay, fine. Then I will say network 1.1.1.0 and 0.0.0.255. Done. Now I'll enable router EIGRP 10 and I will say network 3.3.3.0. Okay. Now the hello packet is about to go out. Now it will say, where is 1.1.0? Okay, the hello packet should go out of 1.1.1.0, right? So hello packet will go here. Now, this guy is not enabled with EIGRP. Will he even respond to this hello packet? Will there be a response? No. Exactly. Now this guy sends a hello packet because I advertise network 3330. Will there be a hello packet back? No. So these two cannot be EIGRP neighbors if they are not connected. Right? Now, let's say if the hello packet, let's say there is a EIGRP. Now, if you don't advertise, if you advertise 1110, then R1 and R2 will be neighbors, not R1 and R4. Make sense? So that is why we say two not directly connected routers cannot be EIGRP neighbors. Is that making sense?
Okay. Is it same for any of all the routing protocol? OSPF,
Same
BGP.
for every routing protocol. That is right.
Okay.
Sir, for OSPF also it will be same or not?
Same thing. Right? For all the interior gateway protocols, it is the same thing. For BGP, we can do even if they are not directly connected, for BGP, we can establish neighborship, even though they are not connected directly. But we will speak about BGP in the BGP classes. Don't worry about it. I'll let you know. Okay, why BGP is different, what makes it different, we can figure out during the BGP sessions. But
And sir, for different protocols, the destination which is for EIGRP is 244. The for different protocols also the destination will be different or same.
correct, good question. So, for example, I want to speak to 93.5 FM listeners. I'll be sending the packets to 93.5 FM. If I want to speak to other users, other listeners, then I have to use other multicast address, right? So OSPF uses different multicast address.
Okay.
Yeah.
So can I know if for the R2, if we are putting there so IP IGRP topology, so what will be the output?
So for R2, what do you want to put?
So IP EIGRP topology.
So you will have all these networks. Network.
So yeah,
It's a list of all the networks.
Exactly. It will show the list of all the networks. Right? So today we have spoken about the the neighbor table. Tomorrow we'll speak about the topology table as well. Right? How topology table is formed, how do they, how do they select any particular things and add it in the routing table? We'll see that in the coming classes.
okay. And can you show us on the GNS3 or packet tracer also?
Definitely. Without lab, the protocols are nothing. So for every theory that we are going to have, there will be equivalent sessions of lab, equal sessions of lab as well. So you will see that everything in the lab again. Okay.
Okay, fine.
Yeah. Any other doubts? Any other confusions?
Yes, can I know for the NRC how much time it will take to complete?
It will take about 1.5 months.
Okay.
Yeah.
Hello.
Yes. So,
Sorry, I missed in the first session.
uh,
So what are will be the
this is
class timings and
the first session that we are having. And the class will be from Monday to Thursday, right? Or Monday to Friday. So Friday, usually I have some